Good evening, students. We will continue with examples and exercises on line spectrum involving all the five series that I have taught you in the previous video. Uh, just for recap, what we have learned in our previous video, we learned five series: Lyman, Balmer, Pascal, bracket, Fun. We learned how to draw the energy level diagram to show the emission spectrum from one level to another level, that is the fallback. We also learn how to draw line spectrum, and we also learn about the formation of line spectrum from the discharge tube, the experiment, right? Now the next part is the calculation and exam question. So we look at the first one. Figure 2 shows the Balmer series of hydrogen emission spectrum, and you can see there they already mentioned it is Balmer series. Okay, that is Balmer series. Just a moment, I changed the color. Okay, so it's a Balmer series of hydrogen emission spectrum. And the moment you see Balmer series, you know the ground state is n equals to 2, right? This is the ground state for Balmer series. Okay, and they say state the electron transition that produces line B. So we have to interpret the diagram. So saya dah kata ketika kita tengok nota dalam video sebelum ini, the biggest gap that shows A is the first line, B is the second, C is the third, D is the fourth, E is the fifth, and so on and so forth. Right? So therefore, our understanding is B will be the second line. Second line in Balmer series. Second line in Balmer series, that is, we have to find the n initial, and we know the n final is 2. That is for sure, because we are talking about Balmer series. However, the n initial depends on the which line they want you to know. So for me, I normally tell my students how to determine the transition. Very simple. Since A is the first line, that means all these are ground state. 2, 2, 2, 2, 2. The bottom of the straight line is all 2 because Balmer series and the ground state is 2. So the first line is always from 3 to 2 because atas 2 exactly adalah 3. Jadi 3 ke 2 adalah transition yang pertama. 4 ke 2, 5 ke 2, 6 ke 2, 7 ke 2. This is how you determine the transition. Easiest way to interpret the line spectrum. So second line adalah daripada 4 ke 2. Okay. The second question. Explain the formation of line B. So how are we going to explain the line of the formation of line B? I will just mention, I don't write here, I just mention, you just listen. You can always listen to the video. The formation of line B exists because of the transition of electron from N4 to N2. Before that, according to postulate number 3, an electron at ground state absorbs energy and promoted to excited state, which is N equals to 4. At N equals to 4, the electron is unstable. Electron fall back to lower energy level, that is N equals to 2, by emitting or by releasing photon of light, and this produces Balmer series. That's all. Okay, specifically produces second line in Balmer series. All right, that is the third one. Now that's the second answer. The third one, calculate the energy of photon that produces line C with a wavelength of 434 nanometer. So they give you 434 nanometer ataupun 434 times 10 to power negative 9 meter. Okay, and they ask us to find the corresponding energy. What is the corresponding energy? So the easiest formula we can use here is delta E equals to HV over lambda. Sorry. We have HV. We know V is C over lambda, right? So we substitute, this is 1, this is 2. We substitute 2 into 1. So delta E equals to HC over lambda. Okay. And H is Planck's constant, 6.63 darab 10 kuasa negatif 34 joule saat. The C is speed of light, 3 times 10 to power 8 meter per second. And the lambda is given 4 point, sorry, not 4 point, 434. 434 times 10 to power negative 9 meter. Okay, negative 9. Mungkin tak jelas lah. Sorry about that. Negative 9 meter. So we see what we can cancel. Second can be cancelled. Meter can be cancelled. So left with joule. Betul. So we calculate 6.63 exponent negative 34 times 3 exponent 8 divided by 434 exponent negative 9. And I get 4.58. 4.58 times 10 to power negative 19 joule. Okay, this is the energy corresponding to line C with the wavelength 434 nanometer. Thank you.